Hello students, welcome back to our YouTube channel Geeks for Geeks Get Computer Science. Just let me know guys if I am audible and visible to everybody. Just give me a quick thumbs up in the chat section if everything is fine with my stream. Okay, yeah, I am audible and visible. Just let me know guys if I am audible to everyone properly. Just give me a quick thumbs up in the chat section guys so I'll know everything is fine with my stream. Okay, Yugashmita is saying that who wrote. Okay, just give me a quick thumbs up in the. I think there would be a an error from my team side, so I'll make it correct. It's support vector machine instead of super vector machine. Okay, it is support vector machine. Okay, so guys, in today's session, we are going to discuss about support vector machine and decision trees, and we are going to solve some of the question based on decision trees, entropy, Gini impurity, like these. So we are going to discuss those topics in detail. But before that, I just want to let you know again our 390 challenge. In this 390 challenge, if you will take any course from 1st of January to 31st of January, you will get 90% of the amount refund which you have paid for the course if you would be continuous in your preparation, and if you will complete 90% of the syllabus in 90 days. Okay, so that would be benefit for you, right? Because it would bring consistency, as you know that your amount would get refund if you would be consistent, right? So learning as well as your money back guarantee is there. Okay, so this is our 390 challenge. Let's come to our topic, which is support vector machine. So guys, let's consider this table, right? Let's consider this data set: temperature, humidity and play. So we are going to play tennis or not, it depends on the temperature and this humidity columns, right? So if temperature is 85, humidity is 85, then we are not going to play tennis. If temperature is 60, humidity is 70, then we are going to play tennis. If temperature is 80, humidity is 90, then we are not going to play tennis. So this is a kind of a data set we have. So let's suppose if I'll get a new query, if I'll get some temperature and humidity, if I want to know that okay, so we are going to get different temperature and humidity, and then we are going to get results. So we have to train our machine so that it would give result. If I'll give different temperature, different humidity, that student, that particular person is going to play tennis or not, right? So I want to know that. Can anybody tell me that why I'm not going to use naive based classifier in this? Can anybody tell me that why I'm not going to use naive based classifier? So if you remember, in naive based classifier we have discussed that all the features all the features should be independent, but here temperature and humidity is not independent. As you can see that as temperature is increasing, humidity is increasing, and temperature is decreasing, humidity is decreasing as well. So I cannot apply naive based classifier. And also, if I'll ask about KNN, right? Why I cannot divide this data using KNN? Can anybody tell me? Because till now we have studied three classification algorithm: logistic, KNN, and naive based classifier. We cannot use KNN. Basically, SVM used when we have a high dimensional data and we have a linear distinguish we can distinguish linearly between them, that we can separate linearly these two data sets. Then we'll say that we'll use SVM, right? Now let's see if I'll plot this data set, scatter plot of this data. So you can see that if I have columns temperature and humidity, if I'll plot temperature on the x-axis and humidity on the y-axis, then I'll get this plot, right? So these black dots shows that students or a person is going to play tennis here, Euclidean here use. Okay, so these black dots shows that we are playing tennis, and these circles shows that we are not going to play tennis if this is temperature, this is humidity. So what I want to do here, I want to plot a line, a best fit line, such that if I'll go through below this line, then I'll play the game tennis, and if I'll not, if I'll above this line, if temperature and humidity, if I'll plot temperature and humidity here, then I'll not play tennis. If temperature and humidity is here, then I'll play tennis, right? I want to get that best fit line. So I can see that this would be the line, right? I can plot this line, right? This is a line, a separating line. I want that. So, but you can see here there are too many separating lines possible, right? This would be separating line, this would be not this one, right? These all would work as separating line. But how would I decide that which of the line is? Why can you tell me that why we how do we find out that which of the best, which is the best fit line? Because there are several separating lines possible. I can draw any of the line. Sadia, we can use KNN here, but in but KNN we usually use when we have some easier data. We can use in this data set KNN as well, but in general, we use SVM when we have complex data set or high dimensional data set. We use KNN because in KNN we have taken a distance, and I told you before that in KNN, if I have a high dimensional data set, then KNN does not work, but SVM works, because SVM does not work on the distance, right? Mainly on distance, it works on distance but not mainly on distance, right? So I want to find out a best fit line. How do I find out a best fit line? So for that, what would I do? Let's suppose I have taken a line here, right? I have taken a hyperplane, we call that line as an hyperplane, we call this as a fit line, hyperplane, hyperplane. And we'll take all the points that are closest to this hyperplane, and we call that as those points, I'll call that as support vector. So you can see that this is support vector 1, this is support vector 2, this is support vector 3. So I have taken 3 points here, and what would I do? And I'll draw a line parallel to this hyperplane and passing through this support vector. So I'll get this line and I'll get this line, right? I'll get these two lines. Now you can see that what I'm doing here, let's say this is some distance and this is some distance. I want to maximize this distance using this hyperplane and using support vector. This maximum distance I have, if I'll maximize this distance, I'll get this hyperplane, right? Let's understand this, right? And this distance we call as a margin, right? Margin is a distance between the support vectors and the hyperplane. First of all, let's consider this. Let's say if we have this line, uh, let's say this is a line x plus y is equals to 4, right? This is a line x plus y is equals to 4. If I'll take, can I write down this as x plus y minus 4 equals to 0? Right? X plus y minus 4 equals to 0. Now let's see this. If I'll take any point left to this line, let's take any point left to this line. If I'll take any point left to this line, let's take the 0 comma 0. So if I'll put 0 plus 0 minus 4 equals to 0, that means minus 4 is less than 0. So that means if I'm taking any points left of this line, we are getting less than 0. So can I write down this region is x plus y minus 4 less than 0? And if I'll go to the right, let's take any point here, 5 comma 5 would be above this line, right? 5 comma 5. If I'll put 5 plus 5 minus 4 equals to 0, so we'll get 5 not equals to 0. I'm just solving it. 10 minus 4, that is 6, which is greater than 0. So that means if I'll take points above the plane, I'll get x plus y minus 4 greater than 0. right? So that means one side of the, if I'll this hyperplane, what this hyperplane is doing, it's giving me a line, and below this line I have all the negative points, and above this line I have all the greater than points, right? Greater than, equal to points, or I can say that positive points. So that means it would divide it into positive and negative, right? A line divides a plane uh, into two parts, positive and negative. This is clear. But here, let's suppose if I'll take any line ax plus by plus c here, ax plus by plus c equals to 0 here. So let's suppose it would give me ax plus by plus c greater than 0 here, and ax plus by plus c less than 0 here, right? So this is what it is doing. So it x comma y when I have two dimensional data. But let's say if I have n dimensional data, then what would be the equation of an hyperplane? If I have a two dimensional data, then hyperplane equation is ax plus by plus c is equals to 0. If I have n dimensional data, then what would be a equation of a hyperplane? Then it would be, let's say, a naught, or let's say, can I write down this as a1 x1 plus a2 x2 plus an xn, or plus an xn plus c equals to 0. This would be equation of an hyperplane if I have n dimensional data. Right, this would be an equation of an hyperplane when I have n dimensional data. Now, can I write down this as a vector? Can I write down this as a vector? Just tell me, guys. Can I write down this as w transpose x plus c equals to 0? W is what? W is a vector. A1, A2, and An. Right? W is a vector, and x is what? X is equals to x1, x2, xn. So I'll take W transpose, and if I'll multiply W transpose into X, I'll get this hyperplane. So in general, can I write down this? In general, let's say if I am dividing any plane, if I am finding out any hyperplane, can I say that its equation is W transpose X is equals to 0 if I am working on in a hyperplane? And I have decided that one hyperplane divides, that one side it would give me positive values, one side it would give me negative values. So let's say if I have find out this margin line which passes through support vectors. So that means this W transpose X, this is what W transpose X plus C equals to 0. Let's take this as W transpose X plus C is equals to minus K. Can I take this as -1? In general, we have in research paper and all, we have minus K, but here I am taking -1. That means it shows that it would be in the negative direction. So any negative value I'll get, I'll write down it as -1. W transpose X plus C is equals to -1. Similarly, can I write down this as, this margin line equation as W transpose X plus C equals to 1? Right? And what I want to do here in support vector machine, because it passes through any support vectors, let's say this one and this one, I want to maximize this distance. Can anybody tell me that how do I maximize this distance? How do I maximize this distance? That means I have to maximize the distance between this line and this line. And why do I want to maximize this distance? Because you can see that if I have some points here, if some points here and some points here, so if these distance gets maximized, then there would be less chances of error, right? That means we'll get the best hyperplane, we'll get the best fit line, so that it would divide all the it would classify the data, right? So that's what support vector machine do. It basically find out the best fit line or best margin line, and best margin line is, I'll maximize this distance. To find out the distance, let's say if I have to find out the distance between these two, can anybody tell me how do I find out the distance? Let's suppose this is a point x1, this is a point x2. If I'll to find out this distance, I'll subtract these 2 points, right? So can I write down this as W transpose x1 plus c equals to 1, and W transpose x2 plus c is equals to -1. And if I'll subtract this, what would I get? It would become 2, and it would become W transpose x1 minus x2. Right? This is a distance. Just one thing, guys. Can anybody tell me that what is a vector and what is its magnitude? What is a vector and what is magnitude, guys? Anyone? So let's suppose if I'll say that this is a vector, right? This is a vector v, right? This is a vector v. Then this every vector has some direction and some magnitude value. That means how much the value this vector holds, and we denote that magnitude by this norm of v vector, right? If I'll find out norm of v vector, it would find out the value between this vector, and if I'll divide v vector divided by norm of v vector, that means I'll get only direction, only direction. It would give me only direction, right? So here I got this distance. If I'll divide with norm of w, magnitude of w, and here as well norm of w, so guys you can see that in the right hand side we get only the distance, right? Because I have divided, I get in 2 upon mod of w, and I want to maximize this distance, maximize this distance, because in the left hand side we only left with that direction. We do not have to do anything. W transpose norm of w, we only get a direction here, so I have to maximize 2 upon norm of w. Magnitude is the root, is the square root of its sum of square. Okay, right? So I want to maximize this distance 2 upon norm of w uh, in support vector machine. And guys, one more thing, that don't get confused with hyperplane with hyperparameter. Hyperparameter is a different thing. Can anybody tell me what is hyperparameter? Hyperparameters are those values which we tune in the machine learning model. Like in knn we have fitted the value k is equals to 3 4 5 and check that which of the k value would work, right? Which would we'll fill our ours by ourselves, we'll say that that is my hyperparameter. But this is hyperplane. We are finding out this hyperplane by maximizing this 2 upon norm of w, right? And guys, one more thing, because w transpose x plus c is equals to 1 here, so can I say that yi is greater than equal to 0 here, right? Why yi is greater than equal to 0 here? Because the example which we have taken, it is giving me no value. So let's suppose playing tennis we are taking as positive, and not playing tennis we are taking as negative. So yi is less than equal to 0. So in the right side it is positive, in the left side it is negative. So can I say that in general that yi w transpose xi plus c is greater than equal to 0? Can I do that? Right? So that means what we have to do in support vector machine, guys, because of this, because we are taking positive and negative, because we are working on science, right? We are working on science. So not playing tennis we are taking as positive, and playing tennis we are taking as yi as negative. So you can see that we have to maximize 2 upon norm of w such that yi into w transpose xi plus c is greater than equal to 0. Why we have taken this condition? Can anybody tell me? Let's suppose if somebody is saying we have to maximize this, I can maximize as much as I want. If I'll take w is equals to 0, right? If I'll take w is equals to 0, this distance get maximized, right? But I have to take some condition. Na? The condition would be that one side it would be positive and one side it would be negative. That means yi into w transpose xi plus c is greater than equal to 0. So I can say that here that, okay, so guys, okay, yeah. So one more thing, because I'm saying here maximize 2 upon norm of w. That means my problem gets reduced to that maximize 2 upon norm of w. Can I say that minimize norm of w by 2? Because I'll take minimum value of norm of w, that would give me maximize value of 2 upon norm of w, such that yi into w transpose xi plus c greater than equal to 0. Right, is it clear? Just let me know, guys, in is there any confusion in support vector machine? Right, how does this work, and how do you get positive and negative value? This is all the mathematics behind it. And guys, it's not possible. You just have to find out the values of w and c, such that you will get the best hyperplane by putting all the values in this data. Okay, so there are not a much of question comes based on support vector machine, but they would ask you that in which case, how support, in which type of data set support vector machine works more. So when we have high dimensional data, support vector machine gives us best result, and if it is linearly separable, then it would gives me optimal results. Right, there are possibility that we'll not get a linear data set, linearly separable data set, then that would work differently. But in this case, that's how this support vector model works. And guys, if you remember in KNN, I told you that KNN is not working on outliers. But let's suppose if we have outliers here, it would work as well, right? It does not make any impact because it is seeing positive and negative values, right? It is only checking the sign. Okay, so guys, this is all we have in SVM. Sometimes we usually use that minimize 1 by 2 norm of W square, because you told me that magnitude formula is square root of some function, right? So there may be a possibility that they would use square, then that would work for us more. Cost function is this: we have to minimize this is a cost function here, right? And we have this condition uh, for our data set, right? This function works as a cost function. Cost function is what, which we have to minimize or maximize. So here we are not finding out the exact error in the test data set, we just checking that how we have to minimize 1 by 2 norm of W square and subject to this condition, right? Just let me know, guys, is there any question in this? A little, yeah, it will not work well for detecting outliers, but it would if I have outliers in my data set, then it would work, right? We do not face any more problem in that. So yeah, for cost function, that would be little bit complex. I don't think that we have to go in so much depth if we have to work for detailed cost function, like what is the error we are getting, right? High dimension means number of features. If I'll increase number of features, high dimension means number of features, more number of features. Okay. Yeah. Next thing we have decision trees. So guys, anybody tell me that what is a decision tree? Decision tree is a flow chart like tree structure that builds a model of a data set based on recursive splitting of the data into subsets. So that means it would divide the data into subsets. Let's say if I want to know that a person, let's say a person is graduated, and I want to know that how he chooses a job role. How, let's say we have a 50 students data, and I want to know that they would go for the 50,000, greater than 50,000 salary or less than 50,000 salary. So I can divide that. This is a root node, and in this root node we have 50,000 students. Sorry, we have 50 students. We have in total 50 students, and then we have one condition here that they want greater than they get greater than 50,000 salary, and they get less than 50,000 salary, right? And let's say we get here 30 students, and here we get 20 students, right? Now in these 30 students we can divide that they are working from home, work from home, yes, and work from home, no. That means they are working from office. Let's say it gets divided further into 25 and 5, like this would like something like that. So that means dividing the dividing the data based on certain condition, we'll get a decision tree. The kernel function would get little bit lengthy, but right now I'll suggest you that you would not go so much in depth, because this is a crash course. I'm just trying to get you a complete revision of uh, all the models, but if you want you can go through it. Yeah, in soft margin and hard margin, we basically add a summation and xi naught something error function, so that we'll get our cost function would be more computational. Right. The cost function does not get more impact, does not get more impact uh, by errors. Right, similarly, so if I'll divide my data set based on certain condition into different subsets, we call that as a decision tree, right? So how does that work? Based on this is also help me to classify my data, right? This decision tree, it based on classification and regression. You can see that here we have greater than 50,000 and less than 50,000 salary. It can be anything, so you can see that it is my numerical data, right? But I have classified this data by taking greater than 50,000 and less than 50,000. That means I have divided into two classes. Similarly here, work from home, yes and no. This is basically classification, right? We have classified that they are working from home, yes, working from home, no. Okay, so let's see how this classification works. So I told you that root node, yes or no, greater than 50,000 salary, yes, greater than 50,000 salary, no. So it gets divided greater, yes and no, yes and no. So we have some root node, and then we'll divide, we'll get a decision tree, right? So let's suppose we have this data. So you can see that we have name, human, python, salmon, frog, bat, pigeon, cat, shark, turtle, salamander, right? We have these animals. So we can see that they have some features which we have written down here, that they gives birth. So human gives birth, yes, python no, salmon no, frog no. So this kind of things. Then they are aquatic animal or not, no, yes, and semi. Aerial animal, no, yes, and has leg, yes and no. On that basis, on with the help of name and the features, we get to know that they get divided into certain classes: mammal, reptile, fish, amphibian, bird, right? We have these 5 classes based on based on classes. Based on these features, we can divide our names into classes, our animals into classes, right? So let's suppose I want to draw a decision tree based on that. So how do I find out? So I have written here this data set. So let's suppose I'll start from the first, gives birth, right? So let's suppose we have a animal here. We have all the animals here. So gives birth, I'll divide it based on gives birth. Gives birth equals to yes, and gives birth equals to no, right? So how many numbers we have in total? We have, if I'll count, 1 2 3 4 5 6 7 8 9 10. In total I have 10. Gives birth yes and gives birth no. So you can see that 1 2 3 4. So we have yes, 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 and yes. So we have 4 yes and 6 no's. Again, I'll divide these 4 values based on aquatic animal, yes or no. So aquatic yes, and aquatic no. Aquatic yes. So let's see how many aquatic. Now we have to consider only gives birth, that is yes. So that means I have to consider only these arrow column. So we can see that here we have no, here we have no, here we have no, and 1 yes. So aquatic 1 yes and 3 no's. And I can see that this aquatic one, yes, it has both the aerial animal no, has legs no. So I do not have to divide it, right? Because we get aquatic yes, and we have only fish here. So I can write down this aquatic animal as fish, right? Now this aquatic animal, that is no. You can see that aquatic animal no, I have here this. So can I divide it into aerial? So let's see. I can divide it into aerial because I have aerial yes and aerial no. And I can see that how many aerial yes I have in this aquatic no, no, no. So we have 1 no and 2 no's, 2 no's and 1 yes out of it. And you can see that if I'll see these 2 yes and 1 no's, this one, all have has legs yes. So I do not have to divide it based on has legs, because it would be only one arrow, right? So aerial yes, if aerial is yes, you can see that if aerial is yes, in this case, this one, this is a bird, this is a bird. If aerial is yes, in this case the animal is bird. And if aerial is no, let's see, if aerial is no, this one and this one, it is mammal, right? So this one is mammal. So you can see that, let's suppose now we get an animal, and then first I'll check that it would give birth or no. Let's suppose it would give birth. I'll go to the side, and then I'll check that it is aquatic or not. Let's suppose it is aquatic, then that would be a fish. I do not have to do anything. Otherwise, let's suppose it is not aquatic, then I'll check that it is aerial or not aerial. Then if it is aerial, it is bird, otherwise it is mammal, right? Similarly, now you can divide this section, give births and no. Now in this give births we have 6 columns. Can you please divide and let me know that what would you get for give birth? Again, aquatic and not aquatic. Aquatic yes and aquatic no. Just tell me guys, how it gets divided, aquatic yes and no, in the cases when we have no. So you can see that one no. Acha, okay, you can see that in this no section, let me write down here. In this no section, you can find out this is no, and this two are no. We have 3 values here: aquatic yes, aquatic no, and aquatic semi. Aquatic semi. So now I can see in this we have one no, two no, three semis, two no's, three semis, and one yes. Right now I can see that this one yes directly gets divided into fish. One yes directly gets divided into fish, so I do not have to divide it more. Now in this aquatic no, that is two. No, this one and this one. So you can see that aerial is, if it is aerial, if it is not aerial, then it is reptile. If it is aerial, then it is bird. Right? So you have to divide by like that. Right, Yugashmita and Sadia. It would gets divided into three. Now this two gets divided, this three gets divided based on aerial, and then you can divide based on has legs or not. So you will get a complete division based on this data set. So that is decision tree. But the question arises that if I have divided based on gives birth yes and no, right? I have gone in this kind of a manner from left to right. But how do I decide that which feature would be the best split, right? Because I do not want my tree to be so much complex. I do not want that it would be so lengthy. I just want that it would get divided at the start, right? So which feature should I choose at the first so that my tree would be short and gives me the information I want? So what would I do? Yeah, that's why I have classification feature. Right, the most important problem in implementing the decision tree algorithm is deciding which features are to be considered as a root node and at each level. I want to know that what would be the uh, what would be the feature I have to choose to divide the tree, right, to take that split. So the relative importance of various features can be found using feature selection measure. And these feature selection measure, we have two feature selection measure, that is information gain and Gini index. So we'll see that how these information gain and Gini index works. Right, I hope you understand that why we are finding out information gain and Gini index. Right, I want to know that at the first I want to divide that table using gives birth feature or aquatic or aerial. Which of the feature would best work if I'll find out if I'll divide it first? Because there may be a possibility that I can take my root node and I can divide at the first that they are aquatic or not. Aquatic yes and aquatic no. If I'll start my table from that, then how would I work? Would it be best? Because there are so many options for us to divide that decision tree, right, to find out different decision tree. So which decision tree works best? So that would I find out using information gain and Gini index. So let's see how this information gain works. For information gain, we have to find entropy. The decision to split at each node is made according to a metric called purity, right? A node is 100% impure when a node is split evenly 50-50. So let's say if I am dividing 100 numbers, so it gets divided in 50 and it gets divided into 50. So it is impure node, right? Why is it impure? Because it is not giving me any result that these 100 data set can be divided be classified into a one particular type of a data set. We are not getting anything from here. So that's why this is my impure split. Pure split is that when all of its data belongs to a single class. So let's suppose if I'll get 5 here and all 5s are fish, then it is my pure split, right? I do not have to divide these 5 values, right? If I have to divide it into 3 and 2 or like that, then it would be an impure split, right? So that's why we have, in order to optimize our model, we need to reach maximum purity and avoid impurity. Right. So basically we have to optimize our model. We need to reach maximum purity and we have to avoid impurity in that data set. right? Let me know if there is any confusion. So we have one term which we call as entropy. Entropy is a measure of impurity in a data set. It finds out that how much impurity we have in a data set for that particular split, right? So entropy of S is formula summation I varying from 1 to C minus pi log 2 of pi. This would give me entropy. So how that would work, let me first see in my data set. So this was my data set, right? So you can see that if I'll see the classes here, we have 5 classes. Mammal, so if I'll count mammal, pi is a probability, right? Mammal, and we have reptile, we have fish, we have amphibians, and we have bird, right? So I can see that how many mammals I have. 1 2 2 mammals, reptile 1 reptile, fish 2 fish, amphibians 1 2 3 3 amphibians, and bird 1 2 birds, right? So we have in total 10. Now I have to find out impurity in this data set. So I'll find out entropy of S, and that is basically summation minus pi log of pi, I varying from 1 to C. C would be the number of classes. You can see here the minus pi log 2 of pi, and log 2 means that it is base of log 2. So it would give me purity in impurity in my data set. So it would become pi is a probability of a particular class. So you can see that it would become 2 1 2 3 4 5. That means in total 10. 2 by 10 log 2 of 2 by 10 minus sign minus 1 by 10 log 2 of 1 by 10 for reptile, and this is for fish. 2 by 10 log 2 of 2 by 10 minus 3 by 10 log 2 of 3 by 10, and minus 2 by 10 for bird, log 2 of 2 by 10, right? This would give me impurity in my data set, right? I can find out impurity in my data set like this. I would get some value. So this is not done, right? This would give me some, let's say, point something value. This is what? This is entropy in this whole data set. But I just want to find out that which with which feature I have to divide. So for every feature, for this feature, for this feature, for this feature, for this feature, for all those 4 features, I have to find out entropy again, and with the help of that I'll find out information gain, and the more the information gain, the more the important feature would be, right? So we for that particular feature we'll get the maximum information gain. We'll split using that feature. So let's see how we are going to do that. First of all, I have find out entropy of my, this is what entropy of my complete data set, impurity in my complete data set, that I got as, let me write down here, entropy of complete data set is 2.2464, right? I got this. Now let's see further. I want to find out impurity in at particular feature, right? So this is a, so for, let's suppose, first I'll find out entropy using this gives birth column. Using this gives birth. Now this gives birth column gets divided into either yes or no. So I'll first consider, let's consider here that yes column. So I'll find out entropy here. So how do I find out entropy for this one? Again, you can see that how many classes in this, 1 2 and 3. I have here 3 classes. So to find out entropy for this class, that it would give birth, S gives birth equals to yes, right? I am finding out entropy for this feature gives birth, right? It would become mammal. So you can see that 2 mammal, 1 bird, 1 fish. In total we have 4. So 2 minus 2 by 4 log 2 2 by 4 minus 1 by 4 log 2 1 by 4 minus 1 by 4 log 2 1 by 4. So this would give me impurity for this feature gives birth, right? So I get here, let's say I'll get entropy S gives birth equals to, yes, I'll get some value here. I have already calculated. So that value would become here 1.5. 1.5. Right, let's erase else, everything else. Now what would I do? I will take the column gives birth, that is no. Again, I'll find out our impurity. So I can see here this, that we have reptile, we have fish, we have amphibian, we have birds. So I have these four. So we have one reptile. How many fishes? One fish, one bird, and three amphibian. I can find out impurity again, entropy again. On solving, you will get this 1.79 as an impurity. You can see that in total we have three. In total we have six. 3 by 6 log 2. 3 by 6 for amphibian, 1 by 6 for reptile, 1 by 6 for fish, and 1 by 6 for bird. On solving, we will get 1.79. So I can see that entropy, that means impurity. So you can see that impurity in my complete data set and impurity after dividing using this column gives birth. What would I get? Impurity gives birth equals to no is basically 1.79. I get this. Right now, using these three entropies, I can find out information gain, how much information I have gained using this column. I can find out, and I told you the more the information gain, the more the important feature would be for that particular split, right? So what would I do here? Let's see. Now I want to find out information gain, and information gain would be entropy of S minus number of entries in my classes and total number of data I have into entropy of that particular class, right? So what does it mean? So you can see that after dividing, it gets divided into two sets, two subsets. Gives birth yes and gives birth no. So that means S V, this V set would become, or I can see that this A set would become yes and no. Gives birth yes and gives birth no. So I get two values here. So that means entropy of S, in total entropy of S was 2.2464 minus summation modulus of SV. So you can see that gives birth we have four values, and in not gives birth we have in total six values, and in total we have 10 values. So I can see here that it would become 4 by 10 into entropy, what we get 1.5 minus 6 by 10 into 1.79. Now I can solve this to get an entropy value. I can find out this this information gain. This is what? This is information gain S comma gives birth, using gives birth data, gives birth feature, right? So if I have solved it, okay, so you can see that we have solved it exactly here. I have already solved it and write it here. So you can see that I got 0.5709. So how do you find, how do you check that this is a good information gain or not? Just tell me guys, that is it good information gain or not? How would you decide that it is good information gain or bad information gain? There is not some anything like good information gain or bad information gain. I told you that attribute that leads to subsets with higher information gain are considered more informative and are given priority during the tree building process. So that means every feature for every feature I have to find out this information gain. That means for every feature I have to find out three values: entropy of whole subset, then entropy of two subsets, or let's suppose there may be a possibility that we'll get three, right? If you remember, in aquatic we have no, semi, and yes. Then I have 3 entropy to find out. That means in 3 classes I am dividing. That means I have to find out impurity at the root node, that what was the impurity I have before dividing in the data set. Then after dividing I get number of subset. In every subsets I have to find out impurity. Then using information gain I have to take impurity in my uh, whole data set, and the classes which I have divided I have to take those subsets, and for I have to take those entropies and find out information gain using that. And the more the information gain, the important the feature for that split, the more consideration is given for that particular split. Yes, this is so. Sadia, this is too lengthy, but yeah, you should know the concept, because there might be a possibility that they can ask a question like that, right? They would give a particular a particular question based on that, and they ask you to find out an entropy or information gain, right? Once you will solve it, you will not find this process is lengthy, right? Every process, every machine learning process is lengthy, because we do not have to solve by ourselves. Machine is going to do that. We just have to code once. But in your exam, you just know all the basics, so that a, if a part is taken from that algorithm and a question is asked, then you should be able to solve it. I'll show you that what kind of entropy question you can get in exam. Okay, guys, there is one good question here. Is there any specific range from entropy? Could be it be negative as well. Just tell me, guys. The formula for entropy I told you was, let me show you the entropy formula. Right, this was the entropy formula. So, can you tell me that how this entropy formula works? Can you tell me what would be the maximum value for this entropy? Achha, these PIs, what are these PIs? PIs are probabilities. Probabilities. That means these PIs lies between 0 and 1, right? So if PI is 0, then what this value would be? If all the PIs are 0. And what does it mean that PI is 0? What does it mean that PI is 0? All PIs cannot be 0, because let's say if I am dividing it into binary classification, right? Either yes or no if I am dividing. So if this is P1, then this would be 1 minus P1. So if P1 is 0, then P2 would be 1 minus 0. That means 1. So you can see that if P1 is 0, then P2 would be 1, right? So you can write down this 0 into minus 0 into log 2 0, that would give you 0, minus 1 into log 2 of 1, and I know that log of 1 is always 0, so we'll get the minimum value 0. And again, if I'll take 1 0, other would be, if I'll take one value of P1 would be 1, other value would itself would be 0, right? So minimum value, this entropy would be 0, and 0 is the best fit. 0 is the best, because you can see that we'll get an impurity here. We are finding out impurity. If we are getting 0 value for the impurity, that means there is 0 impurity. That means that is pure split. So if P1 is 0, 1 minus P1 is 1, so that means all the data set gets divided into this class, right? I do not have to take care of this side of the decision tree, because there is no input value coming in this side of the decision tree, right? Now what would be the maximum value, right? This is the minimum value I can get, and I call that value as a pure split. Can anybody tell me what would be the maximum value I can get here? What is the maximum value I can get in this? Just tell me, guys. I think we earlier calculated that was greater than 1. I told you about the probabilities that PIs lies between 0 and 1. PIs would lie between 0 and 1. What would be the maximum value for entropy here? And guys, I am telling you the minimum value here when we have a binary classification. If we do not have a binary classification, if we have a multi classification, then maximum value can be anything. You can see that we are getting here 2.2464, and we are getting here 1.5, and we are getting here 1.7, right? Saurabh, Rajveer, when you are saying that maximum value of entropy can be 1, it can be 1 when you have only binary classification, right? Yeah, you are right. If I have, let me show you here. If I have binary classification, then maximum impurity when would I get? When I get divided into 50%, 50%, that means P1 is 0.5 and P2 is 0.5. Then I'll get a maximum impurity. And if I'll write down here, what would I get? Minus 1 by 2 log 2 1 by 2, and this summation minus 1 by 2 log 2 1 by 2, right? And on solving you will get this value 1, right? Then you will get a maximum impurity, right? Maximum value of entropy can be 1 if in case of binary classification. I have added one question for this as well, right? This was a question I have added here. Let me show you. Okay, I think the question was not gets added here. This question not gets added, but basically I'll tell you that entropy graph is something like that for a binary classification. This is 0, this is 1, and the maximum value it would take is 1, and it would take maximum value at 0.5. This is entropy, and this is PI value, right? But right, so guys, we have calculated information gain for gives birth column. Similarly, you can find out information gain for aquatic feature. Just this is your homework, just try to find out this aquatic feature information gain. And because I have already calculated it, so I know that for this feature information gain is greater than information gain for gives birth column. So that means we'll divide it using this aquatic feature instead of information gain. Similarly, you can find out information gain using this aerial and his legs. Just right, Saurabh. Okay, so you will get information gain for aquatic animal more than information gain for gives birth column. So that's why you would use, instead of gives birth, you would use aquatic animal feature. And you can see that in aquatic animal, you have to divide it into 3 classes: yes, no, and semi, right? Just solve that. And guys, I told you that we have 2 features to decide that which of the feature we have to use, right? One is Gini index. This Gini index is less computation we have in Gini index. But if I'll talk about which one is more precise, information gain is more precise. So Gini index says that consider a data as having R classes C1 to CR. First we'll find out Gini index of S, like we have find out entropy of S. In Gini index we do not use logarithmic function, we directly find out 1 minus summation I varying from 1 to r pi square, right? So pi is the probability for each of the class. So you can see that for this data set, if I have to find out Gini index, so that would be 1 minus 3 by 10 square minus 2 by 10 square minus 2, because I already told you that we have 3 amphibian and 2 mammals, 2 fish, 2 reptiles, and sorry, 2 bird and 1 reptile, right? So on solving, we'll get the Gini index for this data set. Similarly, what we'll do for this gives birth column, we'll find out Gini split index. right? Again, what is Gini split index? We'll find out, we'll divide it into two data sets, gives birth or not gives birth. We'll find out, and we'll add both the values. First I'll find out Gini split index, and then I'll multiply with number of values in this subset and divided by total number of values in my data set, and then I'll take a summation for both the division, and I'll get my Gini split index, right? Lower Gini values indicate a better separation of classes, so information gain would be more. And if I'll talk about Gini, so lower Gini values indicate a better separation of classes, so we have to minimize the lower Gini we have to minimize the Gini values, right? So you can see that how we have find out in this data set. Okay, so we haven't solved it, just solve it by yourself. This is simple, just try to solve it by yourself and you will get your result. Just let me know, guys, is there any question in this? Saurabh, entropy can be greater than 1. Why? Because if we will consider multi-class classification, then it can go beyond than 1. But it has the same meaning that we have a we have impurity here. But when we talk about binary classification, it would lie between 0 and 1. Okay. So is there any another question, guys? Just let me know, guys, if there is any confusion, any question. Okay, so guys, in the next session, we are going to discuss bias, variance, and uh, class bias and variance, and then we'll bias variance trade-off, in which uh, we'll discuss overfitting and underfitting. And just tell me one thing, guys, if I'll talk about overfitting is common in decision trees, because you can see that how it gets complex if we have a larger data set. So either we'll do pre-pruning or post-pruning, so you can little bit go in depth on these topics. Okay, so we'll discuss that as well. Okay, so yeah, that's all from my side. We are going to continue in the next session. What about regression algorithm? Sadia, what are you asking? Okay, regression algorithm. Guys, for regression, I told you as well. Let's suppose we have numerical data, right? This is classification. So we have to convert that into classification. Like I told you, na, if it is greater than 50,000 salary, less than 50,000 salary, so there may be a possibility that it is 56,000, 55,000. So I'll divide a class. I'll form a class. That means it is greater than 50,000 or less than 50,000, right? So that's how it works. Right? That's how it works. Okay, Saurabh, I forgot to share it today as well. I'll connect with my team and just let you know that they would add that in description box. Okay, ma'am, take one session on PCA, principal component analysis. Okay, so I'll see that next session on next to next session would be on PCA. Okay, so if there is any another question, please let me know. Okay, so that's all from my side, guys. Thank you.